Not too long ago, there was a massive 475,000 square kilometer island filled with forests of juniper trees. However, this massive island, which would have been comparable in size to California at one point, eventually sunk far below the surface of the Indian Ocean. Today, the shallowest point of this former landmass is a whopping 700 meters or 2,300 feet below sea level. The site of this former island marks the southern end of a vast, almost completely submerged continent, albeit a microcontinent, which is known as the Kerguelen Plateau. It spans a vast area covering a 2.53 million square kilometer stretch of crust spanning across what is today a 9,900 kilometer long region. It is notably raised far above the deep surrounding ocean depths, making people wonder, how did the Kerguelen Plateau and its associated microcontinent form in the first place? While the brief answer involves repeated, unimaginably large outpourings of basalt lava termed flood basalts, the more detailed explanation is more interesting. Of course, there are still 3 remaining island groups that exist above this microcontinent today, all owing their existence to active volcanoes. There are the Australian Heard Islands, McDonald Island, and the massive French island group known as Kerguelen, which is 11.9% larger than the size of the U.S. state of Delaware. If only this modern island had a similar population density to that of mainland France, then 880,230 people would have lived here. However, the actual population is only 50. Despite its remoteness and the ability to go where no human has set before on remote parts of Kerguelen Island, it is a far cry from the massive former landmass which once existed to its southeast. The Kerguelen microcontinent began forming a whopping 130 million years ago in the early Cretaceous period when the eastern portion of the supercontinent Gondwana began to break up. This breakup involved modern-day India, Australia, Antarctica, and Madagascar being triggered by the upwelling of a large region of unusually hot mantle, presumably 300 degrees Celsius hotter than the surrounding mantle. Known as the Kerguelen hotspot, the area above its rising mass sent volumes of magma into the crust. Much of this would either solidify as dikes, but strangely at first only cause modest eruptions of lava on the surface to occur, whose remnants can now be found at the Bunbury Basalts in the southwestern tip of Western Australia. Only 10,000 cubic kilometers of molten rock was emplaced across the following 10 million years. Finally, 120 million years ago, the mushroom-shaped head of this rising plume, upon interacting with underlying oceanic crust, began sending large volumes of low silica magma into it. Going into overdrive, the rate of surface lava fusion dramatically increased by a factor of 900, causing the outpouring of some of the largest distinct lava flows Earth has ever experienced, with individual eruptions emplacing thousands of cubic kilometers of lava. Due to the low viscosity of the lavas, it traveled far from its source, building a vast underwater plateau. As the associated tectonic plate moved southwards, the plateau grew in a northward direction. Eventually, around 95 million years ago, the eruptive rate dropped to about 11% of its peak value, occurring at the same time a piece of submarine plateau flood basalts disconnected due to a new plate boundary forming within and then separating it. As a result, the hotspot eventually became centered underneath a northward trending tectonic plate. This created a chain of southward trending flood basalts until 36 million years ago when it jumped back to the now southeastward trending plate. The last major series of flood basalts subsequently built the modern northern Kerguelen Plateau between 36 and 24 million years ago, which Kerguelen Island is not only based upon but primarily composed of. Today, flood basalts no longer occur in this province, although small to moderate-sized eruptions still occur at Heard Island, McDonald Island, and occasional larger explosive eruptions occur at the group of Kerguelen Islands, with the last such eruption happening there around the year 1000. And this is how the second largest submarine large igneous province on the planet formed. Despite involving far more lava than the Siberian traps, they output lava at a lower rate and almost completely erupted underwater instead of on land. This caused the oceans to become partially devoid of oxygen, triggering a minor mass extinction event known as the Aptian extinction during peak activity 117 million years ago. As for the aforementioned major island which existed in the southern Kerguelen Plateau, it likely existed at its fullest extent 110 million years ago and disappeared altogether below sea level only 20 million years ago. While the submerged continent has no very large land masses at the present, the world we live in today would have been very different if such a massive sub-Antarctic island still existed. As a final note, I would like to thank my new patron Richard for supporting this channel.